want to now look at total differentials on the application in ISLM model. Before that, we need a quick recap of what total differentials are so we can apply them in ISLM model. So let's first look at what is a total differential of a function. The total differential of a function measures how a function changes due to simultaneous change in all of its independent variables by summing the individual changes, right? So we essentially want to measure how a function changes due to simultaneous change in all its independent variables. Now let's look at how do we find total differential of a function. Now case one is we have a function of one variable. So the total differential of a function fx, which is a function of just one variable x, is given as df is equal to f prime x into dx. Now f prime x here is just is df by dx, right? It's just the derivative of f with respect to x. So this is the change in f when x changes by 1 unit. Dx is change in x. So when I multiply f prime x and dx, we get the total change in f when x changes by dx. So this is how we find the total differential of a function of one variable fx. It's just f prime x into dx. What if we have a function of two variables? The total differential of a function fxy, here it's a function of two variables x and y, is given as df is equal to partial f by partial x into dx plus partial f by partial y into dy. Here partial f by partial x is change in f when x changes by 1 unit, dx is change in x. So when I take their product, we get the total change in f when x changes by dx. Similarly, partial f by partial y is change in f when y changes by 1 unit, dy is the change in y. So when I take the product, we get the total change in f when y changes by dy. So we can write this more concisely as df is equal to fx dx plus f by dy. Here, when you're a function of one variable, so when you're writing derivatives, you can use prime notation. But when you have function more than one independent variable, you can't use prime notation for derivatives because in this case there's more than one variable. So you won't be clear what the prime is referring to the derivatives with respect to, right? So when you have more than one variable, then the way we represent, so when you have just one function of one variable, then you can use prime notation to refer to derivatives. It's function of more than one variable, then in that case, we can refer to derivatives using such subscript notation, where fx is partial f by partial x, fy partial f by partial y. So the subscript tells us uh, we're taking the derivative of f with respect to which of the variables, right? So this is how we look at, you can find the total differential of function of one variable and total differential of a function of two variables. Now let's just look at quickly one property of the total differential of a function. Like derivatives, differentials satisfy the property of linearity. Linearity means like derivatives, differentials can go inside sums. Differential of a sum is sum of differentials, and constant multiples can come out of the differential, right? So over here, if I had dx plus by, so here we know the differential can go inside the sum. So this will be dx plus dby, and we know constant multiples can come out, which is why the a can come out and the b can come out because they're constants, right? So so linearity means they can go inside, summations and constant multiples can come out just like we have for derivatives. Now later, we're going to look at how we can apply this in our ISLM model.